So if events are mutually exclusive, they have no outcomes in common. And if we were going to write that in terms of a probability that we've looked at, the probability of A and B, if they are mutually exclusive, is equal to 0. This is if they are mutually exclusive. Just a term here that we need to understand, mutually exclusive. All right, you looked at the yes?
What is the thing?
So it's the and. Okay.
This is and. If you watched the videos last night, you would have known that that was and.
What's it mean when it's the other way around?
Union, that's or, and that's what we're going to talk about. The probability of the union of two events. If A and B are in the same sample space, that's an and. If A and B are events in the same sample space, then the probability of A or B occurring your notebook quiz. The probability of A or B occurring is written as the probability of A and the union sign B. This means or. And if they are mutually exclusive, it's the probability of A plus the probability of B. This is if they are mutually exclusive.
So this is dependent. Right.
Well, they just have no outcomes in common. I guess in that case, if they're mutually exclusive, no outcomes in common.
I think it's going to be C.
Not necessarily could you classify it as dependent or independent. Now, if they are not mutually exclusive, I'm going to move this up. If they are not mutually exclusive, I'm just going to abbreviate for time's sake. If they are not mutually exclusive, then the probability of A union the probability of B is the probability of A plus the probability of B minus the probability of A and A and B. I did it again. Habit. All right, an example of this. Say that we are selecting one card from a standard deck of 52 cards. Okay, I'm going to pull one card from a deck of 52. I want to know the probability that we have either a heart or a face card. Now, are these mutually exclusive?
No.
Is there an overlap in the sample space?
Yes.
Who said no?
But yes, there is.
There's a, yes, they're mutually exclusive, or yes, there's an overlap?
There's an overlap.
There's an overlap, and what is that overlap?
Heart and face.
Okay, you could, there, how many face cards are hearts? Three. Okay, so in this particular case, the probability of event A or event B, well, what's the probability of getting a heart?
Like 13 out
13 out
of 52.
of 52. There's 13 of each suit in a deck. What's the probability of getting an ace?
4.
Or, I'm sorry, a face card. I don't know why I was looking at the next problem. A face card.
9 out of 52, which is
How many suits do we have?
4.
4 and
12.
12 out of 52. But then we have to subtract out those that are both a face card and a heart. And how many of those are there? 3 out of 52.
So
Why do I subtract out those that are a face card and a heart?
So it's asking just for
Or.
We have to take out the overlap, otherwise it gets counted twice. All right? So we're taking out the things that are common to both. So in this case, we have 25 over 52 minus 3 over 52, which is 22 over 52. And any time that you can reduce, go ahead and reduce. And this is 11 out of 26. So the probability of getting either a heart or a face card is 11 out of 26. All right, let's do another one. Again, we're going to pick one card. What's the probability it's a club or an ace? A club or an ace. You figure that out. The probability that you're going to get either a club or an ace. Miguel, do you know what we're talking about, the deck of cards? So what's the probability that we get a club? We know it's out of 52. How many clubs are there in a deck of cards?
I don't know exactly what is a club.
Okay, it's the puppy dog toes. Something like, I can't draw. My mother used to call it puppy dog toes. It's one of the suits.
I just want to draw it.
How about if we change it to hearts?
Yeah, that'd be good.
We'll change it to hearts. We'll do heart, or diamonds. We hadn't done diamonds.
This is in front of you when you.
Let's do, if we get a diamond or an ace, how many diamonds are there in a deck of cards? There's 4 suits, right? 4 types of cards in each deck.
Maybe he doesn't know cards.
Maybe, do you play cards? Playing
No,
cards?
I play the Spanish card are different.
They're different? Okay, in our deck of cards, you've got 52 cards in a deck.
Okay.
You've got 4 suits. You've got clubs, you've got diamonds, you have hearts that are red, and you have spades that are black. The spades and clubs are black. Now, there are 13 of each suit in the deck.
13 of each other.
13 of each kinds of those cards. Okay, so if we come back here, what's the probability? We'll go back since I've got a C here and use clubs. What's the probability that we're going to get a club?
13 over.
13 out of 52. All right. Now, each suit, each type of card, the club, the diamond, the heart, has 1 to 10, and then they have 3 face cards, a jack, a queen, and a king. Okay, the one is an ace. Okay, each one has an ace. So what's the probability that we're going to get an ace?
1 over 52.
Okay, we got 52. There's 1 for each suit, 4 out of 52. Okay, good. So now we want to know the probability of getting a diamond or an ace. So if we want the probability, or club and an ace, well, we know we have to add these 2 together. But what did I forget? But what about where they overlap?
It's not 13 over 52 plus
17.
4. plus 4 over 52.
13 plus 4 over 52, that's my 17 over 52, but now I've got to subtract out where they overlap.
Yeah, we need to subtract,
How many aces?
The probability of a club and an ace. Okay, the probability of a club and an ace. I keep doing that. Is 1 out of 52, so I have to subtract. Okay, we got 4/13 on the last question. Here we have a chart that gives us years of service and number of employees. I want the probability of choosing an employee with 0 to 4 years of service. And I'll tell you that the number of employees adds up to 529. To save you that. So what is the probability of choosing at random an employee that has 0 to 4 years of service?
Is that,
What did you say, Sarah?
157 over 500.
Okay, 157 over 529. Okay, and we're going to let that be our A event. So the probability of A is 157 over 529. Now, what if I ask you to find the probability of selecting someone at random that had 9 or fewer years of service? How would we determine that? 9 or fewer years of
so you add
service.
that plus that over that.
Just add to.
So how, add what to what?
Add 89 over.
And then
Okay, so this, we would have to consider 5 to 9 years of service, which is, we'll call that event B. 5 to 9 years of service is 89 over 529. So the probability of A we said or B, 9 or fewer years, is going to be 157 plus 89 over 529. And 9 and 7 is 16, 246 over 529. So that is the probability of 9 or fewer years of service. We have to take each probability into account and add them together because this is an or. So if you have an or, you add and you multiply. Okay. You already did some problems or saw some examples last night. Okay, we have a random number generator selecting 3 integers from 1 to 30. What is the probability that both are less than 12?
Wait, both?
That both are less than 12.
There's 3
Ah, when I type in a hurry, things like that happen. Okay.
So,
So do you want
Let's see, what are we going to do? Let's change it to 2 integers.
easier?
2 integers. Sorry, Okay, what's the probability that both are less than 12? Okay, so we've got to consider here, if you want to, you could think about it, you could draw it out. What's the probability that the first one's less than 12? 11 out of 30. What's the probability that the second's less than 12? Are these
10.
dependent or independent events?
independent.
These are independent events because the first number has no bearing on the second number if it's randomly generating.
So
Okay, and so here we're going to get 11 times 11 is 121 over 900.
So this is an and.
this is, yes. What's the probability that both are less than 12? Okay.
So when you multiply versus adding,
You add if it's an or. If it's and, you multiply. Just add that back in there. Okay, we worked this out for those of you that are watching by video, and we decided that each person had a 0.13% probability of getting their news from the internet, and therefore we used 0.13 to the 10th power to determine the percentage of people that get their news from the internet. So this is the probability that all 10 people get their news from the internet. The complement of an event A, and you've already seen this if you watched the videos last night, the complement of an event A, which we will call A prime, is one minus the probability of A. The probability of a complement is 1 minus the probability of A, because the probability of A or its complement, if these are all in the sample space, is 1. So the probability of the complement is 1 minus the probability of A. If you have a probability of 1, what did we say about the chances of something happening?
1 minus.
It is certain. If the probability of something happening is 1, it's certain. So if A and its complement are the collection of all outcomes in the sample space, then the probability of one or the other happening is 1.
Yeah.
All right. Your assignment on page 707 is 36 to 52 even. We're going to take a test Monday on 9.6 and 9.7. And so we've got our notebook quiz, but I'm hoping you'll have time to work several of these problems before you leave. They're not difficult. But we are going to take our test Monday. Pardon? No, you're in school Monday because we don't have school Friday.